There is a ship sitting on top of three skyscrapers, and it is not fake. It holds a pool, 250 trees, restaurants, and 3,900 guests at one time. I want to explain exactly how that is physically possible. Because once you understand the numbers, you will not look at it the same way again. Let me start at the very bottom, because that is where everything begins. The land Marina Bay Sands sits on did not exist before. It was seafloor. Singapore reclaimed it from the ocean. So right away, before a single column goes up, you have a problem. Reclaimed seafloor is soft. Underneath this site, there are 25 meters of soft marine clay. Clay. Like that does not hold weight well. It shifts. It compresses. You cannot build 3 skyscrapers and a massive roof deck on clay and expect it to stay still. So they went deeper. They drove 1,770 piles into the ground. Each pile is 1.8 meters wide. That is wider than most doorways. Each one goes 40 meters down. To put that in your head, that is deeper than a 13-story building is tall, going straight down into the earth. And each pile took 36 hours to build. Just one. There are 1,770 of them. The way I understand it, every single pile had to be placed within 5 millimeters of its exact planned position. 3 months were spent just marking where each pile would go. Before any concrete was poured, 9,000 tons of weight were loaded onto one test pile to make sure it held. Then they checked every result anyway. This is confirmed engineering practice for large foundations on poor soil. While they were drilling those holes, 300 pumps ran non-stop just to keep the water out. The site is reclaimed seafloor. Water wants to come back in. The pumps stopped that from happening. To me, that single detail explains how much work was happening underground before anything was visible above it. Now the foundation is set. Next comes the concrete core of each tower. This is the central spine that everything else connects to. They used a method called a slip form. Basically, the formwork never stops moving upward. It rises 300 millimeters every single hour. It ran for 18 months straight without stopping. If the concrete stops flowing into it even once, the whole foundation structure is compromised. That means 42-hour continuous pours, no breaks, just concrete flowing around the clock. What I find impressive about this is that the concrete they used is nearly 3 times stronger than what goes into a normal building. Every single batch was tested. This is confirmed. High-strength concrete like this was necessary because the loads coming down from above are enormous. Now here is where it gets genuinely strange. The towers lean. On purpose. Tower 1 leans one way. Tower 3 leans another way. They are not straight up, and the lean gets bigger with every floor they pour. Every column on the leaning face is at a different angle from the one next to it. Not one standard detail exists in the whole building. Every piece of steel, every connection point, was designed individually. When I try to picture the amount of drawing, and checking that requires, it is hard to grasp. The concrete between the towers also had to behave in a specific way because of wind. When wind moves between tall buildings, it speeds up. Between the Marina Bay Sands towers, wind accelerates by 23%. Engineers only found this in a wind tunnel model before the concrete was poured. That discovery changed how the structure was designed. The towers had to be able to move independently in strong wind. There are bearings built in that allow 300 millimeters of relative movement between towers. Tower 1 once moved 4 millimeters more than predicted at level 45. That was logged, checked, and understood. The structure handled it because it was designed for movement, not rigidity. At the same time, the towers were going up. The team was also building the equivalent of 20 football pitches, a floor below them. That is the casino, the shops, the theater, the basement levels. 4 basement levels with 2,500 parking spaces, all built using post-tensioned slabs, so there are no beams in the way. There is a 2,000-seat theater inside the building that floats on 240 springs, so guests hear nothing from the casino above. The casino vault walls are 800 millimeters thick. That matches nuclear power plant specifications. That is not marketing. That is what the actual drawings show. 2,561 bathrooms were built in a factory, not on site. Each one was craned in as a complete unit. Then the facade closed around it. What I think about that is simple. If you build it on site, every bathroom is a custom job done by workers in a tight space. If you build it in a factory, you control quality and speed completely. It was a manufacturing decision applied to a construction project. The glass facade has 2,400 panels on Tower 1's leaning face alone. Not one of them is the same shape as another. $240 million worth of facade panels, each set using a theodolite, which is a precision measuring tool. Not one panel was replaced after installation. That is a 0% defect rate on a completely custom curved surface. The way I see it, that number alone says something about the quality of the planning. Now, the Sky Park. This is the ship-shaped roof that connects all 3 towers. It was built somewhere else and shipped in pieces. Each steel section weighs 90 tons. They were lifted from a barge directly to 200 meters up 24 hours a day for 4 months. The first bolt connecting Tower 1 to the first section took 6 hours to place. Then, that section pulled the next one slightly out of shape. The engineers had predicted every millimeter of that deflection in advance and designed for it. 1,400 bolts at Tower 1 alone. Every single one was tensioned to specification and then marked with paint so you could see if it had moved. The Sky Park sticks out 67 meters past the last tower with no support underneath it on one side. 9,000 tons hanging in open air. This is confirmed load data from the structural reports. The overflow edge of the infinity pool had to be level to within 3 millimeters across 150 meters. If it was off, the waterfall would look uneven. When they filled the pool, the deck dropped 17.4 millimeters under the weight of the water. The prediction was 18 millimeters. The waterfall was perfect. What I understand now about that number is this. The engineers predicted how much the structure would bend under load to within less than 1 millimeter across a 150-meter span, 200 meters in the air. And they were right. That is what structural engineering at this level actually means. The sky park moves in wind. 120 millimeters of movement at the tip during a monsoon gust. It was designed for that. You feel nothing standing on it. 6 layers of waterproofing. Flex 50 millimeters in any direction under the garden because the deck breathes. 250 trees were chosen partly based on how shallow their roots grow, because the structural deck underneath them cannot be penetrated. Every tile on the surface was slip-tested wet. Every tile, because it is 200 meters up, and the consequences of getting it wrong are obvious. The building runs on a scale that is hard to explain. 600 kilometers of cable, enough to power 80,000 homes. Just one building. One pipe, 800 millimeters wide, connects to Singapore's city cooling system. 120 megawatts of cooling installed. 36 kitchens, each designed so it can be fully cleaned without closing the restaurant above it. 8 tons of rubbish every single day sucked through 3.2 kilometers of pipe at 70 kilometers per hour. Invisible to guests. 3,400 clashes were found in the computer model before they became real problems on site. A clash is where 2 systems, like a pipe and a beam, are drawn in the same space. Finding them in the computer saved $120 million. This is now a standard part of how large buildings are built. Marina Bay Sands was one of the earlier large-scale examples of doing it at this level of detail. 10,000 workers built it. 4 years. A safety record better than the Singapore construction industry average. Every life counted. 68,000 defects were logged before opening. 700 were fixed every day. 10,000 were still open on opening morning. That is not a failure. That is what commissioning a building of this complexity actually looks like. You open it and keep fixing. On opening day, it made 6 million Singapore dollars in 24 hours. In year 1, it made 2.7 billion Singapore dollars. That was 15% above what was projected. By 2019, 1 billion photographs had been taken of it. 40 universities now teach this building as a case study. The cost was $8 billion US dollars. More than 5 Burj Khalifas, 1 building, and it was finished on time. Now here is something I did not expect to find when I looked deeper into this. The elevator system alone took serious engineering to get right. The Sky Park Express lift runs from ground to the 55th floor in 36 seconds. That is not a standard lift. Standard lifts cannot handle that kind of speed inside a leaning tower, where the shaft is not perfectly vertical. They had to run 2 weeks of laser alignment work per shaft. There are 15 shafts across the 3 towers. Each shaft was aligned to a tolerance of 0.5 millimeters over 200 meters. To put that in scale, a human hair is about 0.07 millimeters wide. They were working to 7 times that tolerance across a distance taller than most city landmarks. and every lift went through 500 test cycles before it was certified for guests. What I find remarkable is that none of this is visible to anyone using the building. You press a button and go up. The work behind that is invisible by design. The lighting on the outside of the building is also not simple decoration. 40,000 LED lights cover the exterior. Each one is individually addressed, meaning each one can be controlled separately. It took 6 months of night work just to install them. The light show that runs every night since 2010 was built in as permanent infrastructure from the beginning. It was not added later. It was designed in as part of the building from day one. That tells me something about how this project was planned. They were thinking about the finished experience from the very first drawing. Now let me add something that most people never think about. The casino floor has 480 terraces. Every gaming table is covered from 2 separate angles. The entire camera layout was planned inside a computer before a single camera was mounted. 2,500 slot machines are each connected to their own individual fiber optic line. Each machine was individually calibrated before opening. What I find interesting about that is the scale of it. That is not a casino floor. That is a technology network that happens to also have games on it. And underneath all of that, 84 steel rods hold certain floor slabs down because the forces in those slabs actually try to push the floor upward, not down, up. That is a result of the post-tensioning system used in the slabs. The rods resist that upward force and keep everything flat. Most people walk across those floors every day and have no idea that something underneath is actively holding the ground beneath their feet in place. There is also the matter of heat. Singapore sits just north of the equator. The temperature and humidity are high all year. Concrete generates its own heat when it sets. In large pores, that internal heat can crack the concrete from the inside as it cools unevenly. To manage this, 47 temperature sensors were embedded inside key concrete pores. Engineers watched the readings for 72 hours after each major pour. On top of that, 40% of the concrete in this building was poured at night specifically to use cooler air temperatures to slow the setting process and reduce internal heat. That is a direct response to Singapore's climate. The building was designed around the weather, not despite it. So for me, the main thing is this: Marina Bay Sands is not impressive because it looks good. It is impressive because every single number behind it, from 1,770 piles in soft seafloor clay to a 17.4 millimeter deflection predicted to within 0.6 millimeters, was correct. The building works because the engineering was right, not because it was bold. And the fact that 40 universities teach it now is not about the casino or the pool. It is about the decisions made underground, in computer models, in factories, and at 2 in the morning, when a pump broke and 40 workers kept concrete wet by hand, until the replacement arrived 52 minutes later. That is what built it. That is what I understand now.